Hi, everyone, and welcome back to the SSIp here at Cal Academy. My name is Amy Jo, your host, and today we'll be talking to Chloe, another intern here at the Summer Systematics Institute. So Chloe, would you mind introducing yourself with your name, your major, your university, and your pronouns, please?
My name is Chloe Chinidarai, she, her. I go to Vassar College, and I have a double major in a program called Science, Technology, and Society and Biology.
That's very interesting. Science, technology, and in society?
And society, yeah.
And society. Okay, very interesting. So were you always on a track to study those majors?
Well, I knew going into college that I wanted to do biology, but I didn't even know at all about the Science, Technology, and Society program until I took a bioethics class that was in, it's shortened to STS, in the STS department, and I really just loved it. And after I took a religion class that was also in the STS department, I decided that I wanted to major in it and write a thesis in it. And that it would complement like my biology major really well.
Oh, very interesting. And from my knowledge, you're working on your thesis currently. What is your thesis about?
I'm about to start working on my thesis. I'm just doing reading this summer, but my thesis is going to be about the relationship between evolution and evolutionary biology and religion, and specifically Christianity. I think I haven't done too much of the research yet, so I have to look more into that. But yeah, from like a philosophy of science and history of science point of view.
Yeah, awesome. That's very interesting, and you don't hear many people studying science and technology and how religion can interact with science as well. So thanks for sharing.
Yeah.
At what point did you realize your love for science?
I've always really loved science ever since I started learning science in elementary school. Yeah, I've always loved being outside and doing science. And my mom used to call me Curious Chloe when I was little, so I always had a lot of questions. So I think it kind of came naturally to me to do science.
Nice. And was your curiosity ever, let me think of how to phrase it. What kind of things did you collect with your curiosity for biology as a child?
I grew up on a lake, so I would like to look at the fish and just be outside. This isn't biology, but I used to collect the rocks in my driveway and the pretty ones and everything. And I think I would just pepper my parents with questions. Why is this way? Why are the trees like that? You know, all the time. So, yeah.
Curious Chloe. And so what are you studying over the summer during the SSI program?
So this summer, I am studying deep sea octocorals with Dr. Gary Williams. I have them sitting in front of me.
Show us.
Here's the biggest jar.
What is this one called?
It's called Peristinella ramosa.
Oh, does it have a common name?
Probably not.
Probably not.
But if it does, I don't know it.
Getting too niche.
Yeah, maybe. But I'm working on learning about their morphology, and also I'm going to construct a phylogenetic tree of these 15 corals.
Great. Would you explain to us what a phylogenetic tree is and how one is constructed?
Yeah, so a phylogenetic tree is a tree of life. So if you've ever seen the big tree of life about how like mammals are related to reptiles and birds and fish, it's similar to that. So it just tells us how these corals are related and which corals are more closely related to the other ones. and that can tell us about why they might have similar morphologies, which is like similar structures, or it can tell us why ones are different. Yeah, and the way that you construct it is right now I'm sequencing 3 genes from each of the corals, and then so I'm going to find the letters in the DNA, and then using those letters and comparing the differences between the letters of the DNA, I will be able to tell which ones have changed more from each other, and the ones that are more different are more distantly related. And then we'll use that data to construct the phylogenetic tree.
Interesting. Okay, and what is, here, I'll pull up your slides so you can show us, Vassar College, and then you can show us your corals.
Right, so yeah, so this is just a picture of my 15 corals, just spread out so you can see them a little bit.
Nice. And the one we just saw is on the far left, right?
Yes, this one.
Okay. I wanted to ask you, I'm not sure if you know the answer to this, but what is the use of collecting this data and creating these phylogenetic trees?
Yeah, so just like with a lot of the work that's done at the Academy, if you don't know what kind of biodiversity is out there and what and how the organisms are related to each other in the species, then like you can't do any work to conserve it. So it's important to know what's out there. It's also really wonderful and amazing. I mean, they're so beautiful to know what's out there. But yeah, it's useful in the fact that we can learn about how things evolve in general, how things evolve in the deep sea is kind of really interesting, and just so we can know what we have so we know what to save.
I like that. We know what we have so we know what to save. It's a good thing. Okay, and have you noticed any morphological differences between the corals that you're studying? How do you distinguish them?
Say that one more time.
How do you distinguish them between you're working with 3, correct?
I'm working with 15.
15. Sorry.
15. 3 genes.
Yes.
But yeah, so the group that I'm working with is really morphologically diverse. I mean, you can see in this picture, some of them are small and branchy and kind of hard, and some of them are like chunky. There are a few sea pens, which I hadn't really thought about or heard of. But this was a picture of one. It's not super clear, but it looks like an old-fashioned like feather pen. And those are also related. So they're all very different. But the way that historically people have told the species apart is by looking at the sclerites, which are like little fragments of calcium carbonate that give the coral structure and protection. So I can show you on the next slide. This is a species of Nicella. You can see it on the left. And then on the right, oh no, the lights turned off. Hold on.
A little technical difficulty. Okay. On this Tuesday afternoon.
I apologize.
Keeps things interesting.
What?
I said it keeps things interesting.
Oh, yes. Yeah, so the sclerites are these little pieces, and they're like the size of dust. You can't really see them with your naked eye, and they're inside the cell, and they're inside the structure of the coral. And this picture that has color is looking at the sclerites under a microscope, like a regular microscope. And then what I've been doing in addition to that is looking at the structure of them with the scanning electron microscope, which is the black and white image in the lower right corner. And So every one of these corals has different kinds of sclerites, and some of them have lots of different shapes of sclerites. Some of them only have one. You can see this one's kind of interesting. It looks like a little dumbbell shape. Some of them are smooth, some of them are bumpy. And so that's kind of one of the definitive ways to see which ones are different, which ones are different species.
Interesting. And is there any use for having differing sclerite shapes?
I don't know. I don't think that it makes a big difference, but I'd imagine there must be some reason that they're different shapes, but I'm not sure about that.
Perfect. We'll find out, maybe.
Maybe.
I hope we will. What is the most exciting thing you've learned in relation to octocorals?
I think just like the diversity of the octocorals is kind of amazing. I mean, corals are already a very diverse group of organisms, but just these specific ones are so different. They all have different shapes and structures, and it's really kind of crazy that they all like live based on the same kind of basic life plan, but they all look so different.
Great.
That's the most exciting thing I think about them for me.
And how do you think that studying what you're studying this summer is, I guess, connected with evolutionary biology and your majors?
Yeah. So for sure with evolutionary biology, like creating phylogenetic trees, learning how different species are related to each other is like a really like fundamental tool in the toolbox of evolutionary biology, because ultimately like the first step in knowing how things change is knowing how they're related to each other, and just like having a basic roadmap so you know which organisms to compare and how, and you can say, oh, these two are similar. Like, why are they similar? Do they live in similar habitats? Like, did it happen by chance? Like, you know, so it's definitely like the very most basic part of evolutionary biology, I think, is like looking at the genetics, looking at the morphology, and looking at how different species are related. Yeah.
Great. Awesome. And I wanted to ask you, if you weren't studying biology, what might you study, or what else interests you?
Well, if I wasn't studying biology or STS, I really like, I guess this is kind of a cheat, but I really like science communication. I really like video. I took a video art class a couple semesters ago, and I really loved it. And I think that video is a really great tool for communication and for art and for connecting with people, as we're doing right now. So I think I might have done that.
Great, great. And you are doing it.
Yeah.
Currently.
I get to do both. It's very exciting.
Yeah, you're doing it right now. Awesome. And another silly question maybe is, do you have any favorite organisms that you've seen over the summer while working in the field or on any of our trips?
We just came back from the beach and from tide pooling, and that was so exciting for me. I've never been tide pooling. I'm from, you know, the Northeast, like New York and New Jersey, and my favorite thing to see, I would get so excited every time I saw them in a tide pool, was the little anemones. I worked with a professor at Vassar last summer on anemones, but they were really small, and because of the because of COVID, I wasn't able to actually interact with them. I mean, I saw them when I got back to school, but it wasn't the same. And so every time I saw one of those big green anemones, it just was so exciting, and they're so cool. So I think those are some of my favorite, but also I like in the picture that was at the beginning, I like seeing the lizards around here. We don't really have so many lizards in the Northeast either. So
cool. Yeah, I think the giant green anemones are often overlooked, but they're so cool. And
yeah,
they're like common to the Bay Area, but not many other places.
Yeah,
So,
I mean, I don't know. I just think
around.
I just think this. I'm sure they have them other places, but I just think they're so exciting every time.
Yeah. Super exciting. Maybe they're uncommon for like a more landlocked area. Is what I was reaching for. Great. And I want to ask you what you're looking forward to most with continuing through the summer and learning more about octocorals.
Yeah, I definitely can feel myself getting more familiar with at least the specimens I'm working with and their species and stuff. So it's kind of exciting to get to know a lot about one very specific thing. It feels like very rewarding. But I'm definitely excited to work on analyzing my genetics data and putting it all together. I think that's my favorite part of doing research in the research experiences I've had so far is when you get to put it together and it's like a puzzle and you get to see how all of the work you've been doing comes together and what it means for the questions you're asking. And I just really like that kind of work. So I'm looking forward to learning how to construct a phylogenetic tree and to working on it. So
great. Well, we look forward to learning more about your work throughout the summer, Chloe, and we will be signing off for the evening and see you all next week. Thank you. Bye. Bye, Chloe.
Bye.